This is Team 4, and this is our interim report analysis and redesign of an office chair. So we chose an office chair with the general features of adjustable height, comfort, stability when leaning, and mobility to move around the office space. And we chose this product because of shifting work styles due to the pandemic. There's a lot more stay-at-home workers now, and also because of steady demand. There will always be new workers, new students to buy chairs. So our customer groups are career workers and public offices. So going into a little bit more detail, we have some things highlighted. The legs are welded onto a pressure canister that is then fitted into this pneumatic adjuster subassembly, which lets the chair go up and down. It's mobile on caster wheels, and we use various M4 screws to secure everything into place. A little bit more detail into our customer group. So our primary customer group, the career workers, we assume that they are going to be a little bit more wealthy, so they care more about having the best product, and they're going to be using these at home, so daily use comfort, and we want it to be mobile. Public offices, on the other hand, these can be cubicles, so they are really looking for the lowest cost product. Comfort isn't that important, and they can be stationary.
Moving into functional analysis, here you can see our FAST diagram with the task function to provide a seat for the user and primary basic functions to support the user's weight and to allow adjustability in terms of the height, the angle tilting back and forth, and rotation. You can also see our secondary supporting functions, especially one to maximize the comfort of the user. Moving into assembly sequence analysis, our first fishbone diagram as shown here emphasizes modular assembly with the legs with casters, the seat back, and the seat bottom as separate subassemblies attached at the end to the pneumatic adjusters. In contrast, this second fishbone emphasizes a ground-up assembly part by part. In comparison, this second sequence was better for transferring, handling, and locating the parts because individually they are smaller and lighter, but the first sequence was graded out better overall because of the significant advantages in testing subassemblies and parallel assembly.
To show the functionalities of each of the parts of the chair, we created a function component matrix. On the first column, we listed the parts from the assembly sequence fishbone leaves, and in the first row, we listed the functions in the end terminals of the FAST diagrams. This will help us understand how possible redesigns can affect the product functionalities. In our bill of materials, we've listed all of the parts that compose our chair. For each of those parts, we list material, manufacturing processes, and assembly processes, as well as the cost of each one of them. From there, we calculated the total unit cost, which is the cost to manufacture one chair. But it is important to tell that for items number 6 and number 7, we are assuming that piston and valve are 15% of the listed cost, which is an approximated cost from McMaster.
With the component mapping in BOM, we can now suggest mods to the design for DfM. The first is to consolidate the neck and the back. The quad chart below shows the connectors as low functional importance and low cost, so we'll eliminate them. The rests, on the other hand, require a redesign since they're important and expensive. Here's an idea of what that might look like. Next, we improve the armrest assembly. The poles are eliminated, and we redesign the part to be one simple injection molded component that still achieves the arm supporting function. Here's a quick look at that improvement. Third, instead of welding 6 legs together, we chose to redesign the base to be die cast as one single part in one go. And here's a glimpse of that transition.
To serve different customer groups, we broke down our functions into different categories depending on whether or not the customer desired those functions. For our secondary customer group, they did not require premium functions, so support arms, supporting neck, adjusting height, maintaining height, the tilt angle of the chair, and translating the chair easily were not required functions for the secondary customer group. To serve the appropriate functions for the customer groups, different parts were required. We determined that the backrest top, backrest bottom, backrest connector, leg, bottom rest, and base connector were required for the base platform of the product, but the armrest top, armrest poles, height adjusting valve, height adjusting piston, headrest, caster wheel hub, headrest connector and center post could be modified for the secondary customer group to save on costs and produce a cheaper product.
To visualize the differentiation between the primary and secondary customer group products, we've created CAD mockups of the two products. As described previously, the primary group will include a neck support, armrest, height and tilt adjustability, as well as a wheeled base. We have designed the secondary customer group product to be built out of the same base as the primary group for ease of manufacturability. Finally, we have created a modified assembly sequence for delayed differentiation between our customer groups. This fishbone model would first construct the backrest and the seat bottom, as this is uniform between the two groups. We would leave the assembly of the headrest and the armrest for the final step, as this is only necessary for one group.